Hello boys and girls, Mr. Giomini, talking about lesson 411, adding and subtracting mixed numbers. I'm going to take a look here. Now, I'm going to show you two different algorithms that can help you solve this problem. And both algorithms will actually give you the same answer, which is nice. So you have the choice of two different methods, and there's probably more out there, but two different methods that you can utilize to help you solve this type of problem. It doesn't matter to me what algorithm you use. Whatever makes sense to you, whatever is easiest for you, that's what I want you to go with. Let's take a look at the first one. I have 32 1/3 minus 6 5/8. Now we know that when we add or subtract mixed numbers, we need to get these common denominators here. Now the whole numbers, they're going to stay the same for the time being. 32, and I was put here, minus 6 and something. Now in my head, I'm mentally going, okay, I'm looking at the larger denominator, 8, and I'm listing the multiples of 8. 8, 16, 24, 32. And I say to myself, wait, nothing times 3 gives me 8. 3 times 2 is 6. 3 times 3 is 9, so 8 doesn't work. 3 times 5 is 15. 3 times 6 is 18. Too much. Too little. 3 times 8 is 24. So I have found my common denominator. It is 24. Now I ask myself, hey, what did I multiply the denominator by to get this denominator? So 3 times 8 is 24, so I multiply the numerator by 8. 1 times 8 is 8. Over here, hey, if this is 3 times 8 is 24, then 8 times 3 is 24. So I multiply by 3 here, and I get 15. So right now I have 32 and 8 24s minus 6 and 15 24s. Well, right now I cannot take 15 from 8. So what I need to do is I need to borrow. Now, with fractions, it's very similar to when you borrow, when you subtract. Many of you, if you had a problem like 71 minus, let's just say, 39, you would identify immediately that you cannot take 9 ones from 1. You would cross this out, and now you'd make this 6, but this really is, now you have 60. And then you would take that group of 10 that you borrowed and add it to this 1 over here. So you have 10 ones plus 1 gives you 11 ones. Now, if you have 6 10s plus 11 ones, you still have 71. I have not changed the value of the top number. I have simply renamed it to look a different way. Now I have 11 minus 9 is 2. 6 minus 3 is 3. I'm going to go through a similar process with this problem. Now, it's a little trickier because I have to look at the denominator, and it says 24s. So that means each of these 32 wholes that I have, if I have 32 pizzas, that means each of these pizzas are broken into 24 slices. And if I have 32 holes, that means obviously one hole would have 24 slices. 2 holes would have 48. 3 holes would have, let's see, 48 plus 24 gives me 72. What I can do is I'm going to borrow one of these pizzas. I'm going to cross out this 32, make it 1 less. I now have 31 pizzas. But I didn't get rid of that one pizza. I'm actually just going to take that pizza and say, hey, you know what? It's 31 and 24 24s. Because 24 24s is 1 whole plus 31. That gives me 32 pizzas. But I'm going to add that to that extra pizza I had that only had 8 out of 24 slices. And now this side stays the same. Just like when we subtract here, we're not renaming this 39. We're taking the 39 away from the 71. We're making the 71 look a little different so that we can take the 9 from the 1. So this would still say 15 24s. Now what I'm going to do next is I'm going to say, wait, if I have the 31s there, I have the 24 plus the 8. This becomes like an addition problem. Denominators are the same, so they'll stay the same down here. 24 plus 8 gives me, I believe, 32. And we say, hey, minus 6 and 15 24s. Now I can take 15 from 32, and that gives me, I believe, 17. So this gives me 17 24ths, the fraction. And now I'll take a look at the whole numbers. 31 minus 6. Well, if I had 31 minus 1, it'd be 30. Now I have 5 more to take away. So 30 minus 5 is 25. So I have an answer of 25 and 17 24ths. Now I know the numerator is prime, and that numerator is not a factor of 24, meaning that that fraction is reduced to simplest terms. Now I'm going to show you another method. Now in the past I've seen kids like this second method a lot more. And again, you can use whatever you feel comfortable with. Same numbers, 32 and 1/3 minus 6 5/8. Now, obviously, we're still at somewhere down the line here, find their common denominator. But this algorithm is a bit different in that I'm going to first convert them both to impropers. So I go denominator times whole, take that product, add 1 to it. Go denominator times whole, add that product to 5. 32 times 3 is 96. 96 plus 1 gives me 97 thirds. Minus 8 times 6 is 48. 48 plus 5, I believe, gives me 53. And I have 53 eighths. Right now, they look to be up to the same level of work. But here's we go. I see that I have thirds here, eighths here. Well, we already know that their common denominator is 24. I cannot add or subtract fractions when the denominators are not the same. I can multiply or divide fractions when the denominators are not the same, but not add or subtract. Now, again, what we did up here, we said, hey, wait, 3 times 8 is 24. So I have to multiply the denominator by 8, multiply the numerator by 8. Over here, I said, hey, 8 times 3 is 24. That means I have to multiply 53 times, 8 times 3 is 24. That means I have to multiply 53 times 3. Now, in my head, I cannot do 97 times 8. 97 times 8. That gives me, what is that, 56? The 10s go up here. 8 times 9 is 72. 72 plus 5, I believe, gives me 77. So that gives me 776. Okay, let's try 53 times 3. I could probably do that one in my noggin. 3 times 3 is 9. 5 times 3 is 15. Okay, we're almost there. Brain's sweating. I can feel it, which is a good thing. Okay, denominators are same. That's fine. Now let's go ahead and subtract these two numerators. 776 minus 159. This becomes now 60, or 6 tens. I add that group of 10 to the 6. Now I have 16. 16 minus 9 is 7. 6 tens minus 5 tens is 110. 7 hundreds minus 100 gives me 600. So now I have 617 over 24. Okay, still doesn't look like this. What we can do now is divide. Let me erase my calculations up here. I now take 617 divided by 24. 24 does not go into 6. 24 goes into 61. Well, 24 is kind of like, if I round it up to a friendly number, it's equivalent to 20, or it's approximately 25. 25 will go into, this rounds closer to 50 than it does to 75, I would think. 24 goes in, or 25 will go into 50 twice. I'm going to try 24 goes into 61 twice as well. That gives me 48. I subtract. This becomes an 11 because I borrowed a group of 10 from here. This is now 11 minus 8 is 3. This is really 50 minus 40, which is 1. I bring down the next number, which is a 7. Now, how many times will 24 go into 137? Again, I'm going to use some friendly numbers here. This was 25, and let's just say this was 125. How many times will 125 go into 125, or 25 go into 125? 5 times. I'm going to try 5 to see if it works. 5 times 4 is 20. 5 times 2 is 10, with that extra 2 groups of 10 there, so that's 12. I subtract, I have 17. Now, when I have a remainder, that becomes my new numerator. And then the divisor becomes my denominator. So let's see what we have. We have, it goes in 25 whole times, with 17 left over, and my divisor was 24, so it would be 25 and 17 24ths. Hope that helps you figure out which algorithm you want to use. Again, doesn't matter to me which one you use, whatever one you're comfortable with. Okay, take care. I would say that obviously with both, you need to be comfort and fluent with multiplication, addition, and subtraction. And obviously this one, you need to be comfortable with division as well. All right, take care. Bye.